what are the things come to your mind when you look at this picture? You can give your response in the chat box. What things come to your mind when you see this picture? I'm waiting for response in the chat box. Children excited on seeing a candy shop. Super. That's good. Only one response? I need one or more views. Then I will get into that. Yes. Okay, the child is good. The point is, I'm getting you're getting to the point. The child is asking for a candy. Yes. Only if you ask, you will get it. Okay. With this, we will get into the topic. Okay. In the picture, we are able to see that there is a shop and there is a shopkeeper to manage it, and there are kids who comes and ask for the candies which they prefer, right? Which they want. Though there may be many things, they ask what they want, right? And the shopkeeper provides them if suppose they have the needed criteria, that is if it is for it may be a money in this case, right? So this is the scenario, general scenario. Now we apply the same to your client server concept, right? Your server is a shopkeeper, right? Your server is a shop, right, where you have lot of services that you are ready to offer to your clients, right? And there will be server, right, in your that is there will be an app. You can consider it as your server, right, that takes the request from the client and find which is the needed one for their request, pick them and give it back to the client, right? This is a very good example for your client server, right? Today why we discuss about client server means the protocol which we are going to discuss further relating to your application is mostly your client server communication. Whatever you discuss, you always view it in terms of client and server. Client is one that requests for the service and server is one that provides you the service. Now I pose you a question. If there is client, when the client can make a request, I give you the option. When the server is alive, when the server is alive or not, I can make a request. Then only when the server provides me an option, I can make a request. I give you the three options. Or in some, okay, you can give me the answer. From the same scenario, you can get the answer. I repeat the point. Okay, the third option, only when the server provides me option, I can, okay. Right, okay. You can go for more than one options also. Okay, I have a shop. If I can make a restriction that I will sell candy only to the childrens and not to the elder ones, right? This is on my choice. Okay, that in that cases only the provided clients can access it. Then the next case, if there is no shop, right? If there is the server is not available, can I make a request? No, you can make a request only when the server is alive or when the server is open. Sometimes you may get an error, like when you try to access a web page, you may get an error like 401 not found, right? That means the request which you are requesting is not found, or some cases the server not available, the server is down, right? Okay, now you were able to visualize what is client and what is server, right? Now, with one simple question, I will get into the topic. Everyone knows what is web browser, right? Now, my question is a web browser a client or server? Is the web browser a client? Yes, it is a client. Okay, with this understanding or with this recollection, we will get into our today's topic. Okay, and today's agenda is first we will have a glance on what is OSI model. I know you people were familiar with OSI model, but just we will have a recollection to start with our topic. What is OSI model? And then we will see the technology stack of how the IoT protocols are distributed over that. Then we will go for your HTTP protocol. We will discuss what is HTTP protocol, then what is your WebSocket, then what is the difference between your HTTP protocol and your WebSocket. Then we will get into what is MQTT protocol, right? Where it is mainly used. Actually, it is mainly used in your machine-to-machine communication. We will see its architecture, some of its application, and even we will see a demo of that, right? We will see the demo of that particular protocol. Then we will discuss about your XMPP protocol, its architecture and application. Then we go for your conclusion. Right now, we will get into the topic. So, what is OSI model? Before I get into what is OSI model, for how many of them it is a new topic? Only if it is new topic, you can post your message in the chat box. This is a new topic for me. Based on that, I know how depth I want to go for this particular topic. Okay, good. Okay, it is new for, yeah, okay. That's okay. Okay. Then it is a good thing that I want to discuss it. Okay, what is OSI model? If I want to communicate between two persons, you need a communication medium. That's you people know. In the same way, if two computers want to communicate with each other, right, they need some set of rules and regulations that has to be followed for communication, right? For that, you derive a conceptual model, that is your OSI model, Open Standard Interconnection Model, and it was given by your ISO, right? Now you have 7 layers in your OSI model. If suppose if I want to communicate to another system, we will take a simple example, email. If I want to send an email to any of you person, right? Say to the person X, I want to send a mail to person X. I just send the mail. Is the mail being transferred as such? What I see is being transferred as such to the X. There will be some intermediate process. What will happen means, from the application layer, in the application layer, I will be typing the mail, right? There will be one protocol. Let me take it as SMTP, that is Simple Mail Transfer Protocol. That protocol will handle for my mail application. What it will do? It will take information from the user, that is from me. Then it will give it to the presentation layer. All this are virtual layer present in the same system, right? Now, what this presentation layer will do, it will convert, it will check for the syntaxes that is needed for further communication. If I want to do some sort of encryption, all those things will be done in my presentation layer. Then it will start it will pass it to the session layer, which will create a session, which is responsible for creating session with the receiver, right? What is this port? Actually, you have okay. I'll tell you a simple example. The port is like something, is it only one application running at a time in your system? If you open the browser or you typing only one URL, no, at a time you are opening multiple things, right? For simple understanding, I tell you, each one is connected to a simple and a single port, right? I'm not getting into the detail. Then comes your transport proto layer. That is how you transmit with the receiver. You have two protocols, TCP and UDP. TC means you have reliable connection. You first have a virtual connection and then you pass data, or you don't have virtual connection. You simply give the address of the receiver and you make it to transmit. Then comes your network layer, right? Uh, which is helpful for routing, finding the suitable path to my receiver. Then comes your data link layer, that is in which format the data has actually the data, the data has to be splitted into frames for transmission. That is done by your data link layer. Then comes the actual transmission, how it is actually transmitted in terms of zeros and ones, right? Okay, this is what your OSI layer. I tell you what are all the things happens in each layer. So this happens at my sender, and in the receiver it will happens in a reverse way. It's first it receives the data through the physical layer, then it will form as frames in the data link layer, then it will forms as packets in my network layer, right? And it moves to the transport layer, it finds the session, it does decryption or syntax checking in presentation layer, and in application layer it will present my mailer. It happens inverse in the receiver side. Okay. So in the application layer, this is what you are more familiar. You are sending web requests, right? You are typing your URL and you are receiving your web page. All this comes under your application layer. Only the application layer is viewable for the user. Then comes your presentation layer. This is where you do your encryptions. Encryption is nothing but you transform your data into another way so that none of them could read it other than you, right? I'm telling in a simple form. It is like transforming your data into another form, right? So none of them could read it other than you. Then compression is suppressing your data. Translation is nothing but transforming from one format to another format. This level of basic understanding is sufficient for us to proceed further. The next is your session layer. From the picture, you can understand that in your system, you may have multiple applications and you may be connected to multiple servers to identify the unique session. See, a very good example for this is you could have used your online transaction for your bank accounts, right? If you have not made, if you have keep it idle for certain amount of time, you will get a message like session expired, right? You will get a message like session expired. That is taken care by the session layer. It will set the time limit for the session, and in some cases if you break out at the middle and if you restart it, right, you can resume from the place where you stopped, right? All these things happens because of your session layer. These two things we could have frequently encountered: the session expired and resuming from the place where we stopped. Then the next is your transport layer. Okay, the transport layer is simple. You have a data from your application layer. You cannot send the data as such in the same way to the down layer. You have to set, that is, you have to split it. You consider as an example, I have a box, right? I have a box. I can place the data in such a way that only the amount that the box can handle. I cannot place the data apart, overfill the box, right? So I split the data or segment the data such that the data can be fitted in my box, right? That is what segmentation. And in the receiver side, I have to reassemble the data. If I have splitted 1, 2, 3, I should not reassemble as 1, 3, 1, right? I have to reassemble it as again as 1, 2, 3. All this are taken place at your transport layer. Then packet creation. Again, that data will be further divided into packets. Actually, at this point, I will include one more thing. All the data that you transmit in internet, you speak it, you tell it as packets, right? You tell it as packets. So this data will be further fitted into your as packets. We will be discussing about IPv4 and IPv6 protocols, that is meant for network layer protocols. In the coming days, I will give you an overview of what is IPv4 and IPv6, right? That is the one protocol that is meant for creating packets. Then comes your data link layer. Here the data are further divided into frames. Actually, this is how the physical transmission happens. You further divided into frames. Here you will be discussing about your MAC protocol, Medium Access Control Protocol, that we will discuss in elaborate in the coming sessions. The next is your physical layer, where the actual data transmission happens, right? It happens in bit streams. Only the transmission happens in terms of zeros and ones. This is the actual transmission happens. So whenever you have to remember, whenever you send a data, it follows in this way. See, if let the client A be myself and client B be you. So when I send a data, what happens means from my application, right? When I send a data, a header portion will be appended based on the protocol I'm using, right? Whatever may be the protocol. The protocol is nothing but set of rules. I tell you a simple example. The rule may be only I can send, right? Or the rule may be I can send and receive, right? Or I can send only the image, right? I'm telling for simple example. So based on your rules, you will append the header, right? If it is SMTP, then I will append SMTP head protocol. If it is HTTP, I will append HTTP header. Then it moves to the presentation, then it will append presentation layer header. In the same way, at each layer, the header portion will be included, right? And at the final stage, the data will be sent as bits, right? This appended data will be sent as bits. Now you can visualize that if you want to send a single bit of data, right? The header itself will be a large, right? The header information itself will be large for the data. In general, you term it whatever data you transmit, you term it the data portion that has to be transmitted as payload, and the additional information that is needed for identifying your sender and receiver, you call it as header. Right? I repeat it. Whenever you transmit information, you split the information into two ways. The payload is nothing but the actual data I want to transmit, and the information that gives me details about my sender and receiver, you call it as this header portion. Inside the header portion, you will be having header relevant to all these layers, right? Okay, this is the general model. Now it is the general template given for a transmission. So when you transmit, it is not that you have to follow all these protocol layers, right? You may skip some of the protocols based on your need. For example, now I move from this OSI to your IP protocol, that is to your IoT protocols. Now your IoT can be viewed as three-layered architecture or five-layered architecture or seven-layered architecture. It depends. In general, we view IoT as three-layer architecture, where you have only your perceptron layer, network layer, and application layer. Your perceptron layer will include your physical and data. What is perceptron layer? Where you have your sensors to sense the information, right, and pass it to the outside world, right? You have a general abstraction that is your perceptron layer. Then you have your Next, that is your network layer where you communicate with the outside world. Normally, that will encompass your network and transport together. Then you have application layer where you integrate all this functionality will be provided by your application layer, right? So in this way, you have it as 3 layer, or you have it as 5 layer, where you have data, physical and data together, network transport separate and application separate. So it depends. Now for further discussion, I will consider the 5 layer stack. Now I put a hold. If you have any doubt, you can post it in the chat box or you can unmute and tell. Then I will further proceed towards the technology stack for the 5 layer protocols. Yes. If there is no doubt, you can just type proceed, or if you have doubt, you can type the doubt on that on the chat box. Okay, let me proceed. Okay. Any persons who type it as a new topic, they can give their response. Any persons who type this is a new topic for them, they can give the response. Yes, that's what I'm asking, whether to proceed or want you have any. Okay, okay. That's fine. Okay. Now, when you surf in the net or when you refer any papers, you have for IoT, you will be saying 3 layered architecture, 5 layered architecture, and 7 layer architecture. Why means when you implement your IoT application, if you are following the functionalities, or if you are clumping the functionalities of layers together, if 2 layer functionality is clubbed together, you may have a reduction in the number of layers. Why I club the layers together? The main thing is I want to reduce the packet size, right? If I have multiple layers, I will have my header itself will be a large enough, right? Okay. So this is the basic understanding why you reduce your number of layers. You can club the functionalities of layers together. That is only the conceptual understanding which generally all application need to be followed, but you can club it. Okay. Now, let us discuss here. In the application layer, right, these are all the protocols supported in your application layer, different protocols supported at the application level, right? The most important thing is your MQTT, COAP, Constraint Application Protocol, and your MQTP, QP, that is Advanced Message Queuing Protocol, and your XMPP. Now, today we will be discussing about your MQTT and your XMPP. Then coming to your network layer and physical layer, see this functionalities can be clubbed, and what are all the protocols I may be using here is I may use your TCP/IP, right, which is meant for your net transport, and I also use your IP RPL 6LoWPAN is specific for your IoT, which we will be discussing in elaborate your 6LoWPAN. Then comes your I am clubbing your physical and data link layer together, right? Here we will be discussing most of these protocols, your Bluetooth, BLE, Wi-Fi, all the protocols listed here we will be discussing in elaborate, right? This is the technology stack we are going to follow further for our discussions, right? Now, let me start with the, okay, ma'am, how I try this layers practically. Okay, okay, if you want to try it practically, you can visualize, you can simulate it as, in the same way that you have a you write one program for application layer, you write another program that is meant to be your transport layer. When you send data, you virtually, right, you virtually write a program that appends the header to visualize how it is being transmitted. You cannot physically view it. You assume that how it is moving on. It is a set of routines built in, written in built, right? So if you want to try this layers practically, today I will show you one layer, application layer protocol, that is MQTT, but you can visualize only the abstract level applications. The underlying principles you cannot visualize, you cannot practically do it, but you have to visualize it. Got the point? Because that is not relevant to the application developer or the user. It is not okay. When you can practically check means when it is in your hand, right? When it is in your hand, if I'm asking you to do multiplication, that is in your hand. Either you can write it as repeated additions or you can directly write. It is in your hand, in the developer hand, so you can visualize it. But if it is not in your hand, that is how you transmit, right? Physical layer, whether I want to transmit in a little Indian format or big Indian format, it is not in my hand. It is in the hand of the physical medium which I am using, right? Only you can study and appreciate how the layers are working, but you cannot practically modify it. But you can understand the concept. For example, in transport layer, you have one concept called sliding window protocol. That is, sender side you will have one buffer and receiver side you will have one buffer. The reason is I should not send messages, more messages, such that the receiver is not capable of receiving all them. That time I have to wait when until I receive the acknowledgement. Only I receive the acknowledgement from the receiver, I will send the other data. All these things you can visualize, you can write it program and you can try it. Again, you do it at the application level, right? You can visualize it. Am I clear your point? Shall I move further? Yes, okay. So today we will be discussing about your HTTP, MQTT and XMPP. In the next session, I will take your COP and AMQT. Okay. This protocol, we are using this protocol without our awareness or not. See, whenever you type any of the URL is nothing but your website address. Whenever you type your website address in the browser, you are making use of your HTTP protocol, right? When you type, you are using your HTTP protocol. Then this request, this is a request, right? This request will send by your client. Your client is nothing but the web browser running in your system. This will send the request to your server. What the server will do means the server will take this URL, right? And then it will find the relevant program or document for this particular URL. It will fetch it and it will return the response back to your client, right? And this happens with the help of your TCP IP. That is, I am making use of your IP protocol at the network level and TCP protocol at the transport level to achieve this functionality of my HTTP. In the same way, whatever may be your application protocol, that application protocol has to make a choice of its transport and network layer protocol for making a communication. At this point, I put a hold and I explain it in elaborator. Since some person stated it is a new, I just explain it. Hmm. So I have a choice of picking my application protocol based on my application. The protocol will be used. Now, whatever may be the application protocol, that is, application is nothing but the user data. If this user data has to be sent to another system that is connected in the internet, then I have to make a choice for my network protocol for routing. Routing is nothing but if you are going to your friend house, you know where is your friend house, and to reach your friend house you may have multiple paths. You have to pick which path you want to use to reach your friend house, right? In the same way, I want to know what is the destination where I have to send this data, and to send the data I may have multiple paths. I want to decide which path I want to pick. All this functionality is not provided by application, it is provided by your networking protocol. So I have to pick which networking protocol I'm going to use, right? Then the second question, okay, I may be going to my friend house, right? Not for doing only one job. I may ask him. I may first ask how are you, or I may get some. I may borrow some books, or I may return back some items. I may give sweets, right? I do multiple things when I go there, right? You consider that is you do multiple sessions, right? So your transport protocol you gives a unique identification, right? Actually, here I'm clubbing your session and transport. For which thing I am doing, right? First, IP is meant for reaching your friend house, and TCP is meant for doing which activity in your friend house. And this is how you understand your TCP and IP. So, whatever application you use, you have to decide which transport and which network protocol you use. In your HTTP, make use of your TCP IP, right? With this understanding, I get back here. So your server returns a response, and that response is displayed in your in your browser. This is how a simple program client server works, and your HTTP protocol is a request response protocol. What is request response? Only if I request, I will get a response. If I don't request, I will not get any response, right? I will get a response only if it is available. So my availability and is given by the means of this status code. If 200 means it is successful, your operation is successful and you are getting a response. And very frequently we could have encountered the status code 404. That is your resource not found, right? That we could have frequently encountered when we search for some pages or books that was being removed, right? Okay. Am I clear? Shall I move further? Please do response. Shall I move further? Yes. Okay.
Yes, ma'am.
Fine. From now onwards, whenever you type your URL, you should remember you should remember that it is a request response protocol, right? And it uses your TCP and IP for your transport and networking. Okay. The next comes, this is a connectionless protocol. What is connectionless protocol means? See, when I make when the client make a request to the server, right? When it gets the response, then the physical connection will be terminated. It will not maintain the connection. If I want to say, if I send another request, then it will establish another connection. If I send 100 requests, right, then 100 connection will be established between your client and server, right? You may think, why I need to have this. You consider an example, right? This is to have a even distribution of work. If suppose you have a, you're going for a shop, right? You have 5 customer. If a customer A is asking for 10 items, if I am serving 10 items repeatedly, then I am making wait for other 4 of my clients, right? They may get tensed. So what I do, I first serve the first client, then I serve the second client, then I serve the third client, then I get the, if I want to, if it is urgent for the first client, I will assign 2 persons for the first client to get the items for him as needed, right? So that is the your connection list. For each request, you have a separate connection. What is media independent? You using your HTTP protocol, you can get your image, you can get your audio, you can get your video, you can get your web page. Your web page is nothing but which you see it on your UI. So it is media independent. It is not that for this media, if it is image, I have to use it in a way. No, it is not like this. But you just specify it, what kind of data you are using. Then it is stateless. It don't remembers you, right? Once the session is closed, it will not remember you. If you go for the next time, it will ask what you want. It will not remember what you said earlier. That is your stateless protocol. Because of this feature, it is not much help in your e-commerce where you have to remember your states, right? That is why there comes your web servlets, all those concepts, but I am not getting into that detail. Why I specify this point means you may ask, okay, I am using e-commerce, right? I'm typing the website address Amazon, I'm going inside it, I'm making a shopping cart, but it was able to remember my choices. No, that comes your servlets, all those concepts which remembers your state, right? It is at the high level view. Okay. With this understanding, I move further. So by this point, you should have known what is URL. URL is nothing but to uniquely, okay, it creates a cookie. Yes, if you want, you can create cookies. Cookie is nothing but it is an additional feature where you make it to remember on the client side, not on the server side, right? That is in your web browser, you're creating cookies to remember what things you typed, but this information is not stored in your server side. You are right. The cookies is on the client side. Shall I move further? Am I answered your question? Okay, that's good. So this is your URL, which we were more familiar, right? You give this is how you type your web address, right? Whatever you type, even if you type your host name which you want to access, automatically the protocol will be appended. And actually, you can give your port number. See, you can give your port number. That is optional. That is optional for HTTP. The default port number is 80. Then you give the path which you want to access it. If I want to access this particular page, I have to give the path. Actually, you have several methods for you can when you request when you make a request, you have several ways for making your request that you can see elaborate in this page. As of now, I tell you 2 simple methods which you could easily visualize, right? You have get and post method. Get means whatever information you're sending to your server side will be appended in your URL. You can check it. For example, in your Google search, you type something, right? You type something and you click next and see your URL page. In the URL page, what you have typed to search will be appended. That is the example of your get method. There you don't have security. Then next is your post method. It is like you post your letter. What you do, you put your letter inside an envelope, right? In the same way, the information that you want to send to your server will be placed in the header. For example, if you fill a form, or in your when you log in into your Gmail, you give your username and password, right? This password you cannot see it in your URL. If it is so, what will happen? You can everyone can pick it up your password and they can do the things, right? That is sent through your post. These are the two important methods you should remember if you are using your HTTP, and which you can visualize it, right? Okay. So this is the basics to understand your application protocol. Then I'm moving to your WebSocket communication. Okay. Shall I proceed? Yes, okay. What is WebSocket communication? You may not be heard about this WebSocket communication much. Before I start WebSocket communication, I tell you one thing. We were discussing about your HTTP, and do you remember the mode of transmission that we discussed in the previous session? Data transmission mode. If anybody remembers, they could just ping in the chat box. We were discussing about data transmission mode. I give you a clue. You have half duplex. Okay. That is transmission control protocol. No, I was saying about data transmission. Okay. Yes, serial and parallel transmission. That is how you transmit your data. And then we were see transmission mode, right? Transmission mode. That is simplex, half duplex, and your full duplex, right? Simplex, half duplex, and full duplex. Simplex means one-way communication. Half duplex means at a time there is only one communication, and full duplex means can have both communication, right? Your WebSocket helps me to provide full duplex communication, right? It is same like your HTTP, but it supports me to give your full duplex communication. It is different from your HTTP, but it is compatible with my HTTP. Sometimes people say it is an upgradation of your HTTP, right? I repeat the points. It is considered as an upgradation of your HTTP, and it is also compatible with HTTP, but it is not HTTP. It provides additional features. It provides full duplex communication. We will see it is mainly used in your video conferencing, and where you need quick kind of responses. See, it is a two-way interactive communication between the user, browser, and server. Uh, where you can the server also can send and receive event driven response. What is event driven response? If something happens, I have to respond. That is event driven response. On occurrence of an activity, I have to respond. That is your event driven response, without having to pull the server for a reply. So this term may be new. Pooling. I tell you what is pooling. See, okay. We will take the same shop scenario. I am interested in a particular candy. At that time, the server, that is the shopkeeper, is not having that, or he is preparing for that candy. I am periodically going and asking him, is it prepared? Is it prepared? Is it prepared? Right? When it is prepared, the shopkeeper will tell me, okay, it is prepared, you get it now. Right? So I'm periodically asking, right? Is it prepared? Is it prepared? That you call it as pooling. I'm repeatedly asking the server for my information. This is because I should not waste my time if he has prepared. But I should not. I'm so curious that I want that information as such. But for that, I'm wasting my time. I'm repeatedly pulling. This thing can be avoided in your WebSocket. What will happen in the WebSocket means, initially I will post that I need this candy. I need not to periodically ask the shopkeeper. The shopkeeper once prepared, right? He will get me the information. Okay, you come and get it. That is what two-way communication. See, uh, that is pushing the data, right? The server, once this is the normal thing. I request URL, you get your HTML page. This normally happens in your HTTP. If I have my WebSocket connection, and the connection is established, when the data is ready, the server can send back the data to your client. And parallelly, your client can also can push the data. This is what you call it as two-way communication, right? This is the simple understanding, and this is sufficient to appreciate the difference between your HTTP and WebSocket. So, in simple words, as I told, before and after, okay, before HTTP, I periodically ask, is there any message for me, any message for me? When you get the message, your HTTP server will respond. But here, it automatically tells me the information. This is what you also call it as event driven. When there is an event of hello, it gives the message to your response. So, as a simple thing, in terms of mode of communication, your HTTP is half duplex and your web is a full duplex, and messaging pattern, it is request response. Only you request, I will give the response. I will not give response without your request. But WebSocket, it is bidirectional. Uh, Pushing your information, it is not actually supported, but it can be done by adding additional features. But it is the core feature in your WebSocket. So here you have moderate overhead per request or connection. Here you need to have little bit overhead because you need to maintain your connections as such. Okay. Now we get into our MQTT, which is our concern. Why we have seen all those HTTP means you need to have a review on your communication protocols. Only if you have an overview and basics, you can understand the next level. Okay, what is MQTT? Message Queuing Telemetry Transport Protocol. From the word message queuing, you can say that there will be one queue where you can post your messages, and those who are interested can get the message from the queue. It is a lightweight protocol. Why it is lightweight means whenever I speak weight, from now onwards in the protocol you have to assume the weight as the size of your header. I repeat that thing. Whenever we speak lightweight in terms of IoT, you have to in respect to protocol, right? When we speak lightweight protocol, it means that the header portion of the protocol is minimum. When I speak lightweight in terms of any algorithms in your IoT, then you have to consider that lightweight as minimum computation time. Right? Now, for this discussion, whenever I speak the word lightweight, you have to understand that the header portion is minimum. In your MQTT, the header portion is only 2 bytes. Right? Okay. Now, so it is a machine-to-machine protocol. It is specifically designed for machine-to-machine communication, and it is a lightweight publish and subscribe protocol. What is publish and subscribe? Okay. Publishers are nothing but the creators of data. Am I right? Who can publish? Only those who create can publish. So your publishers are nothing but the sensors, right? They are the publishers, right? And they publish in a on a particular topic. I get into it. What is the topic and what is the broker? Okay. And your subscribers are nothing but your end devices which are interested in the data. For example, I am interested in temperature data, right? I will pick the temperature data from here. I will subscribe it. Whenever there is a temperature data posted into my broker, I will get that information, right? This is the subscriber. Okay. You have only small code footprint. That is, you have minimum header length, so you have only minimum bandwidth consumption, right? Okay, it is based on central topic. We will discuss what is central topic. Then both the publisher and subscribers are autonomous. They are independent of each other. Now, uh, are you are you clear with this publisher subscriber, so that I will move for the next explanation of what is this broker? Yes. Are you clear with publisher and subscriber? Please post it in. Oh, okay. What is API? Okay. API is where you encounter the word API here. Application Program Interface. Am I told anything about it here? Okay. As you ask the question, I will explain it. This API. Okay. This API builder. Okay. API builder is nothing but I tell you a simple example which you can understand. You have your keyboard, right? You have your keyboard and you have your processor in the system. How do they interact with each other? You have one device driver, right? That act as an intermediate between your keyboard, whatever may be your device. For this example, I pick it your keyboard. That act as an interface between the device keyboard and your processor. In the same way, your API act as an interface between the application development and the underlying transformer. For example, I tell you abstract level understanding. You have Aadhaar, right? The Aadhaar database is with the government, and you're going to develop one new application, right? And for that application, you decided that I will use my fingerprint as a authentication or recognition mechanism for my application. You need not to create an entire database for of all the persons. What you do, you know already the database of fingerprint is in the Aadhaar. What you do, the Aadhaar is providing some APIs, right? That is interface mechanism methods. In simple, they are nothing but methods, and in that method they will have some parameters. In this example, I picked the parameter as fingerprint, right? If I pass fingerprint to that particular method, it will go for Aadhaar database and it will find the matched Aadhaar number and it will return back to my application that Aadhaar number. Right now, this method which takes my fingerprint as input and returning my Aadhaar number as output is the API. And actually, this kind of API will be provided by the owner of that application, and you have Aadhaar API. In the same way, all the programming. Today also we will see a demo of this MQTT broker. They are also providing API to publish and subscribe. In simple, I need not to know about background knowledge, how it is implemented. I just want to know what I want to send and what I will get. What I give, what I get. Only that information is sufficient if I use that API. This is the logic behind that. In simple words, it is an application program interface and it will be a method where you will have parameters and you will have return values. Is it okay? Okay. Okay. Now, what is I tell you about the broker, then I will come to these 2 points because this is not our interest, this is our interest. First, I speak about the broker, then I come to this MBAS and your NoSQL DB. What is this broker? This broker is like your shop, right? I told server as your shop, right? In the same, your broker is like a shop where you put all the things what you want to save and the client come and pick it up. It is a common place. The broker is a common place or the server. In your MQTT, we will not call it as servers, we call it as broker, where the clients will publish and subscribe, right? I use the word client, where you publish and subscribe. That means your publishers and subscribers both are termed as client in your MQTT. This is the important point which you should not get confused. In general, we speak if the receiver as the server. It is not the case. In MQTT, you call both the publisher and subscriber as client, right? You call this broker as your server, right? Okay. Now I tell about this MBAS. This is a mobile-based software service. That is, it helps to it helps your mobile devices, right? It helps your mobile devices to connect with the database. In simple words, it helps your mobile devices. It is a service that helps your mobile devices to connect with the backend services. Backend means your database services. And what is this NoSQL DB means? You don't want to get worried much. I tell you a simple example. Okay, you could have seen your Excel sheets, right? In the Excel sheets, if I have serial number, student name, register number, then that is a structured data, because you have to enter only three values. What is your serial number, what is student name, and register number, right? You have a structure. If suppose you are writing an email to me, right, do you follow any structure, right? You know, you can write whatever things you want. You can add your images, anything that is unstructured, right? The database for maintaining such unstructured thing, you call it as NoSQL. This understanding is sufficient as of now, right? So now I move for the next topic. Okay. Now I want you people to visualize MQTT with structured query language. It is structured query language, that is SQL, is meant for structured database, right? That is, I told, as I don't want to get into the depth, I stopped it. What you tell SQL is for a structured database. You are right. And what I told is NoSQL. It is not structured database. You have MongoDB, so on. Actually, when you go for IoT, you will be using MongoDB. That is a NoSQL database, right? You are right, Prashant. It is what we discussed is not SQL. It is NoSQL, not SQL language. So MQTT example, you visualize your TV, right? Now I want you people to visualize how your TV works, right? And give me an example for in your TV, what is subscriber, what is publisher, and what is your topic, and what is your channel. I give you a minute. You just visualize and map it with an example. You have TV, you have lot of channels watching over there, right? Even you do subscriptions for particular channel, right? With this example, you just try it and list out me how you can map it to your MQTT. Okay, TV is the subscriber, channel is the publisher. Okay. So let me see what are all the things. See, your publisher is the cable company, right? And your broker is the internet provider, right? Your subscriber is your household TV, right? The channels which you want to view is the topic. You are interested in that particular channel. In the channel, you will have lot of things coming, right? If you take a Star Sports, it is not that only one sports item, only one specific sport is coming. If you take a okay, any channel, you have lot of programs coming over that. The message is the program, right? The message is the program, and the topic is the channel for which you subscribe. You is nothing but your channel. That is your TV. That is you. You are the thing. The broker, how you get it? You get it through some. You think it of your smart TV, or if it is normal, then it is the channel provider, right? And the publisher is one actually creating that creation of the channel. If you are subscribed for Sun TV, then Sun TV is the publisher, and you have subscribed for that, right? From the broker point of view, both are the clients. Okay. With this understanding, right? With this understanding, that is, we will move further for the topics. Okay, I have some problem in moving over. Okay. Now comes how it is used in IoT and how it is related. See, at the application level, that is at the what the user can view, right? The user can view sensors, right? So now the sensor is at the application level. So I have sensors, and that sensor it will be, it can publish, and it will be the publisher, and it will be also the subscriber. Now here you have to understand that in application I may have sensor as the publishers, and my mobile phones, right, which gets the response is also an application, right? Okay, so my sensor will be a publisher, my mobile phone will be a subscriber, but both I term it as my MQTT client, right? Then I use TCP IP connections to make connections with my broker. My broker is nothing but the server, right? I establish a MQTT session. I have to establish a session that may be either for publishing or may for subscribing. When I establish session, I want to tell in which topic I am interested, right? This is the general overview. So the same thing is repeated here. Your client may be written in any programs, and your servers are nothing but the brokers. You call the brokers as the servers, right? Okay, these are the things we discussed. Okay, what is the topic? The topic of interest. See, okay, the topic may be you consider. I will in later sessions. I will show you one cloud platform called ThinkSpeak, where in the ThinkSpeak you create a channel for each user, right? And in the channel you can create more fields. Fields is that if I'm measuring 5 sensors, if I have temperature and humidity sensor, you will create a field to read the value of temperature and humidity sensor. That will be your topic. Different set of items you are publishing is the topic, and for that topic, if temperature sensor reading is one topic, and I will get different sensor values at different period of time, right? That is your messages, right? The topic is I am interested in temperature sensor, and the messages I am passing different sensor values. Okay. So this MQTT session, where it can be a transient or durable. Transient in the sense, if I missed some intermediate messages, I cannot get back it later. That is your transient. Even if I am off at a particular period of time, when I resume my session, if I am able to get back the missed informations, then I call it as durable subscription. So you can have either transient subscription or durable subscription. Okay, why the important thing about your MQTT is your HTTP on the one, it don't provides your QoS, that is quality of service. How quality your service is. At most one means the receiver, right? The receiver will receive at least one copy of the he will receive one copy of message. For example, if the sender believes that the receiver have missed a message, it may send a duplicate copy, but one or more, that is the receiver will receive at least one copy. More Then at least one means you will receive only one copy, right? There will not be any duplicate. And you may not also receive message 0 or 1. Either you receive, or either you may not receive, or you will receive the message. Then exactly once means you will receive only once. The very good example is your billing system. You should receive only one. You should not miss the message, or there should not be any duplicate. So this three kind of quality service is provided by MQTT. You call it as QoS 0, QoS 1 and QoS 2. If you provide QoS 0 service, the bandwidth requirement will be small. When you go for QoS 2, it will be higher. The complexity will also be higher. More the service, more the complexity. Okay, where I am using this MQTT in the real world application. Your Facebook Messenger make use of this MQTT protocol. Why? You have only low bandwidth usage. In your Facebook message, you become followers of someone, right? When you become followers, you get information about, you subscribe and you're getting information, right? That is what publish subscriber. And low power usage, why they are specifically using MQTT is to reduce the power consumption in your mobile because of this phase, that is low power, and it supports many to many, right? You can have many publishers, many subscribers, and it is scalable, right? It is scalable because of this low bandwidth, low power usage, scalability and interoperability. It is mainly used in IoT applications, right? And we will see a simple example, real-time example. If suppose I'm having a pacemaker inbuilt in my client, right? That is the sensor on the patient. It can use MQTT protocol, right? The user has to get subscribed and this information is subscribed by the system present on the doctor side. So whenever there you have to send there is an emergency, that will be sent to the doctor through alerts, right? This is the practical applications where you make use of your MQTT. So these are the differences. Your HTTP is a document, it is a data centric. There you use your request response. Here you use publish and subscribe. Your MQTT is simple, but your HTTP is complex because it handles variety of media data types. Then the message size is small, as we discussed. Then here you have three quality of service, at most, at least, and exactly once. Okay, now I have given you two YouTube links. I'm not going to play it now. I will share it with you. It is good if you watch these two YouTube videos. You can appreciate how you can build your MQTT. Now I will show you a demo on how to work with your MQTT. Okay. See. Mosquito broker. This mosquito broker is an open source software or server that supports your MQTT. It is freely available, right? It is freely available, open source, which you can download it in your system and you can try this protocol, or if you can directly connect it to their server without installing and you can work it out, right? Now what I have done is I have installed this mosquito broker system in my system, right? Now first step, if I want to work in a client server environment, what I want to do, first I want to start the broker. That is, first I want to start the mosquito. So I'm opening my command prompt. Are you people able to view my screen? Yes, okay, okay. Okay, okay, that's good. Okay, now this is the place where I have installed my broker. Now I'm just going to start the server. So what is the command to start the server? I just want to type mosquito. Now I have started my server. The next step, I want to subscribe. Either you, okay, you have two commands. The first command is for subscription and another command is for publishing. First, I will run the subscriber command. Why means when I publish, if I have subscriber only, I can read it. If I first show you the publisher, I cannot show you how it is being received by your subscriber. So I first run my subscriber. So I have opened another command prompt. Now I'm going to subscribe. See, you can have more than one subscribers and in the same way, okay. So I am going to create another subscriber. I am going to create two subscriber for study purpose to explain it. This is one subscriber and I am going to create another subscriber also. Now I have two subscribers, right? And the subscribers are interested in test, right? They are interested, they are connected with the publish test and they are interested with the topic name as topic. Okay. Now I have two subscribers and I have started my server or the broker. See here you have to term it as broker. Now I will create. I will create another screen for publisher. Okay, let me look at the command for publisher. See, this is the command that is for this topic. I am going to send this particular message. Okay, if I have it into why I'm making it small means when I copy paste it, it may get an error if it is in two lines. So I just minimized it. Okay. Okay. Now I have published the message. My message is hello world, right? And I am published and the topic I am connected with the server, right? The name test and the topic and the name of the topic is topic. Now for the subscriber the message has to be delivered. See, this is one subscriber who have received the message. and hello world in the topic test, and again I will show you have another subscriber. We had two subscriber, right? This is for publishing. This is your broker. Okay, one subscriber. Okay, here I have not entered it, so it has not received. I will publish the message again. See, I have received the message. I have received the message, right? I had two subscribers and both of them have received the message. Okay, in real world, how it will happen means if I have sensor data, right, I can give that sensor data, I can program it and send my sensor data through the publish, and those who are subscribed for that topic can receive it. Here, this can be virtually, okay, this can be practically done using your intermediate. Even in, you can consider a cloud as the broker and you can work it out. I will in the later classes, when there is, if there is time, and I will tell you some basics of Python, and I will show you how it could happen using your Python. This you can check it in your system itself. In the previous, there was one question whether we can visually see your layers of protocol. This is normally it is easy to view our application layer. This is an very good example of viewing the functionality of your application layer protocol. So in the same system, you have installed your server, you have installed your client. I had three clients. One client publishes and two clients subscribed, and the server is Mosquito server. Okay, with this I stop my,
Ma'am,
and I go back to
ma'am,
the next protocol, and I'm not going to show you this video, but after I will share it with you, you can view this video. They are good to view it. Okay, the next is your extensible messaging and presence protocol, and I tell you this protocol you are using daily. You people are using this protocol daily, like your HTTP, you are using it daily. I tell you the features and I just check you whether you are able to find that. What are the characteristics of this XMPP means? You can form groups. That is, you can create groups. You can also have publish and subscribe model. You know, now you are familiar with this, what is publish and subscribe. Then it supports asynchronous mode of communication. What is asynchronous mode of communication means? Uh, the sender and receiver need not be in align when the message passing is that. The very good example is your email. You are the receiver. If I send the email, it is not that you have to be in live to receive my email. It is not like that. When you come alive, you receive your email, right? This is an asynchronous mode of communication. That type is supported. And the important thing is your presence, your status, whether I am alive or not. Your status can be seen by everyone. So can you guess what type of app you are this is using? Yes, you are right, Manju. You are, it is WhatsApp. It is WhatsApp. Your WhatsApp is using your XMPP protocol as a basics for instant messaging, right? It also uses other, but for instant messaging, it makes use of your XMPP. For to make your voice call, right? To make your voice call, it uses VoIP. I'm not going to get into that. So you want to understand, for instant messaging alone, it uses your XMPP. Okay, as I told, it is extensible. Your MQTT is mainly meant for your machine-to-machine communication. It is meant for, it is an open source project. It is meant to use in any kind of applications. It mainly meant for sending messages and real time. And this XMPP protocol has extensions, right? It have extensions to support specific features of IoT. I have not get into that in elaborate, but you know that it has specific extensions to support your IoT. Okay. This is the example to explain your XMPP. You can have your wired connection or wireless connection. How the users are uniquely identified in your XMPP. Okay, that topic I skipped. I missed in your MQTT. How in your MQTT the users are identified means they will create when they subscribe. They will have a channel ID, or you call it as your broker ID, through which they were identified. Here you have your how you create your ID means you call it as Jabber ID. You have a node, that is the username. Then you have the domain, to which domain they were connected. See, you have different domains, to which domain they were connected, and the resource name appended. This is how you create Jabber ID, and in your XMPP you call it as Jabber ID, not your address. Okay, this list the protocols. This is theory portion. It is open, it is decentralized, it is secure, flexible, diverse, all those things. Okay, and it is mainly, the main thing is it is mainly used for chatting, and it is used for alerting, which is an important thing in your IoT application. So you make use of your XMPP. And this is what I discussed in WhatsApp mobile. How your Jabber ID is created means your mobile number, and the server is your WhatsApp, and the resource you are using is your mobile. And many of the instant messaging company, you could have heard of the Zoom and Jitsi, right? And all this are making use of your XMPP. Okay, only it is for instant messaging. No, it highly supports your IoT by having supporting all type of communication patterns. See, your MQTT supports only publish and subscribe, but your XMPP supports request response, asynchronous messaging, publish and subscribe, even subscription. All this are supported by your XMPP with different extensions. Right, with different extension, it supports your XMPP. You can have a glance in this website for different types of how it supports different types. Okay, oh, I forgot it. I have directly displayed all those things. I just want to post a question. What is this? Okay, now I have given you the answer also. There is one network called adaptive network topology that is meant for multicast wireless sensor network. It is necessary to be in the same network if we want to transfer locally. Okay, I couldn't get you. It is necessary to be in the same network if we want to transfer locally instead of using server. Necessary to be in the same network if we want to transfer locally instead of. Okay, I come to this point. I take the question. I split this question into two parts. Within the network, if it is within the network, I don't need any network addressing. If it is within the network, there is no need for network layer protocol. We will be discussing about your low range communications, where you don't discuss about your network layers, right? If it is in the network, then there never comes your network protocols. Then what is server? Server is one that provides you the service. That's simple. Okay, if there is a, as you have asked about server question, I will introduce you another network called P2P network. To explain this P2P network, you were familiar about your torrent. You could have used your torrent for movie download. Or you people heard of the torrent? You could have heard. You can have fastest download if you use your torrent. The thing is BitTorrent. The thing is it uses peer-to-peer network. There you don't have differentiation between client and server, right? There is no differentiation between client and server. all the systems have equal privileges. That is why you can have faster access. If I want a particular file, you post it, I want a particular file. Whatever system that has that file, they will send it to me. Right? All of them will send to me. And in the same way, if somebody is asking for that particular file and I am having that file, my system will transmit the data. That is your peer-to-peer network. In that such kind of network, you don't have server. As I don't want you to introduce much network concept, I just introduced what the things needed to you. I think I have answered your question. If you want, you can check your peer-to-peer network. The very practical example that you could have used is your BitTorrent software. How it works as asynchronous mode, which means our messages are stored in. Yes, of course, it is asynchronous mode, right? Well, even if you are not in online, your messages are stored somewhere, and when you come to live, you get that messages. That means the messages are being stored, and for the information, you have it as backup, right? If you select backup, it is stored and you can get it anytime. And even if you not select your backup, it is stored in somewhere. That's why when you come into Alive, you are able to get that messages. It is asynchronous mode. I think I have answered the questions. I'm getting back here. The ANT is a type of multicast wireless sensor network, and it is a proprietary network, which means it is not open source. Okay, why I want to introduce this network means in networking you have one communication called multicast communication. That is a group communication where you can transmit from one to many persons or many to many persons. For example, we have used Telegram where I am sending information to multiple persons, one to many, right? In your WhatsApp group, anyone can post to anyone, or in your Google Tools, many to many, right? Multicast many to many and one to many. Now, as a home assignment, I want you people to know what is IP multicast. Okay, it is not a biggest thing. Don't worry. If you just type IP multicast, you will get to know. I just want you people to get introduced to the term. What is IP multicast and what is the reserved address for this multicast environment is given for your IPv4 and IPv6. In the next class, I will take you two more application protocols in IoT, and I will start introducing you the communication protocol one by one, because the communication protocol is theory portion. You cannot show it visually. So I will take it up one or two with the application protocol, which I can show some demo to you for better understanding. Okay. If there's any questions, I can take it up, or we can wind up the sessions. Yes. Okay. So if it is, there is no more question, we can wind up the session.